All
right. Okay, today I'm going to present about Android game development. See if I can get this full screen. There we go. All right, so a little bit of introduction. I've been at Clearwater for 5 years, and I've been developing Android apps for about 2 years. I have, as you saw before, I have about a dozen Android apps in the App Store, both Google Play and Amazon App Store. Most of my presentation is going to be, well, some of my presentation is going to be based off this book called Beginning Android Games by Mario Zechner. He has a good reference book on how to build games for Android. Some of the concepts are from there. And then I only have about an hour, so this will be a brief tutorial. You're not going to be a wizard at developing games after this. Just an intro to get you a little bit more idea of whether you want to invest that time to learn it. So there's a few different types of games that you can sort of categorize into a few different buckets. You can think of board games like Monopoly or Risk. These can be easier games to start with because there's not a lot of animation required. You also have puzzle games like Sudoku or Where's My Water. These can be easy also, depending on what type of puzzle you're developing. And if you want to get a little more complicated, you can do arcade games. So Fruit Ninja, Snake, anything where there's lots of animation sprites going around. That can be a little more difficult to program those interactions. So if you're new to this, you'll definitely want to start with an easier type of game like a puzzle or a board game. And also, if you have any questions throughout the presentation, feel free to ask. At a very high level, you can think of an Android device as having a set of inputs and a set of outputs. Some of the inputs that we have are an accelerometer. This is what tells you the tilt of your device. And it has X, Y, and Z coordinates, so you can see pretty much any tilt that your phone is doing. So whenever you rotate your device and it flips to landscape mode, it does that because of the accelerometer. It knows that you're tilting it. And all Android devices are required to have that, so you know that if you're developing for Android, it'll have an accelerometer in there that you can use. Touchscreen is also one that all Android devices have. There is a difference between a fake touchscreen and a real touchscreen. Fake touchscreen is where you have like a mouse pointer type device where it's not really, you're not directly interacting with the screen, but it's sort of emulating that. So all Android devices need, oh boy. Let's restart that. Am I still recording? Yes, good. So like I said, all Android devices have a touch screen, and so you're pretty much certain you can use that. There are a few things Android devices don't all have. When you think of gestures, pinching and zooming, some devices don't have multi-touch, so you have to be aware of that. Camera and compass, not all devices have those either. So you want to make sure which ones you want to use, and based on that, which devices you're able to program against. If a device doesn't have one of those things and you require it, in the App Store, when you go to it, your app won't show up for that user because that certain feature isn't available. And then you can think of what outputs you have on an Android device. The most obvious is the screen. And I'll delve into that a little bit more. And then we have this sound and vibration are another different outputs you can use. Sound can be useful. Vibration you want to be careful with. Some people don't like it. Me in particular don't like when it shakes for different things. But that is available for you to use. Okay, so let's get a little bit into the screen. There are a few different ways to program for the screen itself, the graphics for the screen. One of the ways is just using the Android widgets. This is the simplest way of throwing something together, but it's also lacks the most. It doesn't have much flexibility. So you have a bunch of widgets available to you just through Eclipse or whatever IDE you're using, it'll often have a WYSIWYG editor where you can drag and drop things onto your panel. So you have things like text view, buttons, image view, progress bar, the basic UI elements you'd expect to have access to. This works actually quite well for different board games, even puzzle games. This is all you need most of the time. But like I said, it's not very flexible. You don't want to build Mario or something with animation out of widgets. It's just you're going to have lots of trouble. So one example I wanted to show you, one of my apps that I made just out of using Android widgets is this game called Word to Word. And I should be able to play it right here. Yep, test drive now. So this game, I just used the Android widgets provided. You'll see these buttons, easy, medium, hard. Those are all just buttons. But you can even overlay an image on top of your button. So these tiles are just buttons by themselves with an image on top of it. So everything you see here are just a lot of buttons. Buttons, text, and layouts is basically the whole thing's driven off that. And for some games, that's really all you need. So if that's possible to just use these widgets, then I would definitely go that route. Or if it's your first time developing, definitely try it out first with the widgets that are provided before you get into something more complicated. The next thing you could do is bitmaps. So if you want direct control of the image on the screen, then the next avenue to use is just using bitmaps. And what a bitmap is, just a 2D collection of pixels that you have access to and that you can change pixel by pixel. You can draw things onto your bitmap. You can draw icons or sprites onto your bitmap and do it that way. So it's very flexible. It's also very simple to do. It's very easy to understand how it works. But you can't get very great animation with it because it takes a lot of time for the device to render bitmaps very smoothly. So you can see the animation can be jittery. If you have more than a couple sprites on your game, then it can slow down and not look very smooth. But I definitely want to consider that if that is a option. So again, I'll show you another app I did that does use bitmaps. Risk it. So there's not a lot of animations in this, but there is more complicated graphics than what you'd expect for like word to word that you saw before. And so this is just one large image that it's updating every time you click on it. And there is a little bit of animation, so you can zoom in and then drag it around. And so there's very simple animation, but again, it's just one large image panning and scrolling. So in that case, it is feasible to use bitmaps. Anything else about bitmaps? Okay, so the book I referenced at the beginning has a great framework of how to interact with bitmaps. It sort of abstracts some of the concepts away so that you can deal with the concepts instead of the lower level underlying stuff, which is useful for bitmaps. The framework comes in handy a lot more for using OpenGL, which I'll get into next slide. But it is a helpful abstraction to sort of break down the steps into easy, understandable parts. And the last thing you can use is OpenGL. Anyone know what OpenGL is? So it's a 3D rendering engine for many devices. iPhone has a OpenGL, Windows, Macs. Pretty much everything has OpenGL available for it to use, and it's very popular because it's open. I think it's open source code. So it's really a 3D rendering engine that's been optimized for using for complicated graphics, for 3D, 2D rendering, and it's very powerful and it's very flexible. But again, with power and flexibility comes a lot of complicated code. So it is quite a hurdle to get over to try to understand how it works. And what you basically do for OpenGL is you define the geometries that you expect to see in your scene. You give it a location of objects, the size of it, the color, the lighting, everything you want about that scene, and then you give it to the rendering engine and it renders it for you. So you interact with the geometry and then the engine renders it for you. Because it's been optimized and it gives you very smooth animations, you can have lots and lots of sprites and lots of things happening inside of your game, and it does very well with it. And the book that I reference also has the same framework. Because it's abstracted away, it uses the same framework for OpenGL underneath, and that's very useful in this regard because it's so complicated. It's nice to use the framework instead of just the low-level OpenGL programming. Any questions on that? All right, so let's get into some concepts of games that you have to address. So collision detection. Like these two soccer players are colliding. It is a very difficult problem to figure out when two objects collide. And the thing that complicates it is objects aren't just squares often that you have to see. Do these two squares intersect? They can be very complicated objects and you could have hundreds of objects interacting with each other. And at that point it becomes difficult because you have to check every single object against every other object. And like it says here, that is an order of n squared operation because you don't know which ones will collide with which. So when you have more than a few objects, that can become very slow. And so there's a few different ways of dealing with this. I'll go into one method that is often used in game development. One solution is you do the collision detection in two stages. You have a broad phase and then a narrow phase. What the broad phase is, so this nice image of Mario. You can see lots of different objects in here. You think, okay, Mario, you'll have to see what Mario collides with. But there's a lot of other things that needs to know what they'll collide with. So those Koopas or Oompas or whatever those are called, the brown sprites, those have to know when they collide with the pipes. They have to know when they, when they fall off the edge, they need to know that they no longer have anything underneath them. So a lot of these objects are doing collision detection. So in the broad phase, you can divide your scene into this grid. And you want to make your cells of the grid large. The book says about 5 times the size of the largest object. And then each object, you want to try to find which cells each object spans. And this isn't an exact science, so you just want to get a good guess. And the quickest way of doing this is you sort of draw a box around your image, and then you say, okay, look at the 4 corners of the rectangle and see what cell it falls into. And that's very quick to do. This doesn't guarantee that it'll fall in that cell, but it's a good guess that it will. And so for each object, you quickly assign which cells they fall into. So for example, Mario can fall into 2 cells. And because we made ourselves large enough, you know at most an object can only fall within 4 cells. And that's only true if you know your cells are larger than the largest object. So once you have that, then all you need to do, so this gives you a bunch of potential collisions. So within each cell, you say, okay, now you only have to look at the objects within each cell instead of the objects within the world to determine if they collide. So you've cut down your list quite a bit, and then you actually have to do the collision detection amongst those objects. So I discussed you can use a rectangle to bound your object, but you could also use other things. So you could use a circle if you want. Collision detection for a circle isn't too bad. You can also divide them into triangles, into sub-rectangles. Probably easiest to just do a bunch of rectangles. If you need that fine detail, then you just do just break it up to more than one rectangle. And then, so to check the collision between two rectangles is relatively easy. There's sort of three states you have to check. So do the rectangles intersect? That's that first example with the red and blue rectangle. Do the rectangles completely, are they completely separated? So they don't touch at all. But you have to be careful with that one because the third state, you could have the rectangles not touch at all, but that's because one is inside the other. And so you have to check sort of those three states to make sure that they really do not collide at all. All right, moving on. So that's it with collision detection. The next thing you often have to deal with in game development is how you're going to save state. You don't want someone to be playing their game, switch to something else, and come back and they have to restart the level. Now, Android device will keep something in memory as long as it can. So often you can go to a different app and then come back, and by default it'll just be there because it's still in memory. But the operating system allows it to evict any apps when it's running low in memory. And so you don't know at all when it will evict your app. And so to be safe, you need to, anytime someone switches to a different app, it's safe to save that data at that point. There's a few different ways to save that data. One is SQLite. So every Android device does come with SQLite. And so by default, you have access to a database. Each app is given their own section, their own database that they can use that's internal to that app. And you can, it's sort of, so it is SQL, but it's very simplified. So you only get access to a few different data types. Like you see here, you only get integer, real, text, and blob. So there's no date. If you want a date, you're going to have to represent it as an int, as an integer, or represent it as text, however you want to do it. But then you do get access to, you can index your data, you can do basic stuff you expect from SQL to make it very quick lookup. So SQLite is great if you want to do some complicated data storage. Yes?
So if you have a person playing the game, would you at certain times save it in the background?
Yeah, that's probably a safe thing to do. You really don't need to save it at any time. The time you need to save it is it'll give you an event when it's saying it's going to exit your app, or when it's pausing your app. You get events, and at that time you can save. But just to be safe, it's probably nice to, every once in a while, just push out a save.
So if you're running low on battery, and let's say I put my phone down for a while, and it's running low on battery, I would get an event that battery's low, and then you could run the save routine?
I'm not sure for the low battery what it would do. I don't know if it fires an event at that point. But yeah, to be safe, you could just, every 2 minutes, just push out a save, just force save it in the background. And that's what I do in my games. If it's a turn-based thing, I'll automatically, when it's your new turn, it'll save without you knowing it. And then it's just careful if some weird error happens and it automatically quits your application, you have that saved state. So SQLite is good. It is a bit heavy. You have to open the database, manage it correctly, close it. You have to. It's just a little bit heavy for some applications. So if your application is pretty simple, I would advise not to use SQLite. So the other option that you have that I like is shared preferences. It's basically a key value map that you get access to on your app. Each app gets its own shared preferences. You can choose to have it private or public. Private means you can your app alone can open it and view it and save to it, where public means other apps can do that. And basically, we'll just walk through some of these lines. To use it, you first have to get it. Context, every app has a context that you get access to. So you're just calling, I want shared preferences, and then this name allows you to, maybe if you want to have different different types of things you want to save, you can divide it into different maps. But this is just, generally I'll just do the name of the app that I'm doing. So tic-tac-toe, you want it private. And then to get anything out of it, you're just like a map, you say, I want to get, but you define what data type you want. I want to get int, the name of the key, and this will be a default value. So if it doesn't exist in there, it'll return 0. If it does exist, it'll return whatever is stored in there. So that's getting stuff out. To push stuff in, it's also very simple. You still have your preferences over here, and you say you want to edit it. Then you put, just like a map, again, you have to give it what data type you're doing, and you give it the key and the value. And it is, you have to call commit. It is done atomically, so you set a bunch of things you want to set, and you sort of put it all, save it all as a transaction. It does it all at once to protect against weird situations that can happen. So that's actually very simple to use, I find, and it's pretty, for most apps I've done, it's sufficient. Yeah, it's good enough. Quickly going back to database, so there was one instance where I found database to be useful, and if we go back to the Word application, or the word-to-word, now if you remember, when I first started it, it says installing dictionary. Let's see if we can see it again. So installing the dictionary. What I used to do, so there's a large dictionary of words, like 30,000 words that I need, and I want to put it in I put it in a set as valid words that you can use, and then anytime you choose a word, so in this game you have to go from by to me, and you can only change one letter at a time. So if I do like BB, that's an invalid word. You can't do that. Well, my app needs to check, is this word valid? So it used to just look in that map, and if it was in that map, it was valid. The problem with that is I had 2 devices at the time. One was a newer phone, and one was an older phone, like 4 years old. The old phone ran out of memory every time it tried to build that map. It was just too much for it. And so the way I got around that was when I first install the app, I take a file that has all the words and store it in the database, put an index on it to make it fast. And every time you try a word, it's actually going to the database and looking up that word. And because it's indexed, it's quick. But that way it can be stored. It doesn't have to all be in memory at once. It can be stored in the database and gets around that memory problem. So that's where our database I found was useful. But all the other apps I've done really have used just the shared preferences. Any questions on those two? All right, the manifest. Every app has to have a manifest in Android. There's a few things that are in this manifest. I'll go through a few of these. So right here you have your package. This is actually very important. I'll go into a little bit later why that package is important. But you want to make sure each app has a unique package. So if you develop 2 apps, you want to make sure they have different package names, because anytime you install one or the other, it's going to get confused of which one's which. It identifies the app with this package. The version code and version name tells you the version of your app. So if you want to do an update, you need to bump these versions up. Now this is the one. This is an integer that the Android actually uses. This is the one that matters. You just bump that up from 3 to 4 when you're ready to do an update, and then you push it onto the App Store, and then the App Store manages telling the users that there's a new version ready to download. I'm sure you've seen on your phone before. It'll say either you have them automatically installing updates to your apps, or you manually do it. It knows that by this. If you push a new version to the App Store and don't update this, then no one will get that notification, because it doesn't look like it's a new app, a new version. This is the display version. This is just for users. When you do an update, this is what it'll display. So that's useful if you don't want to show an integer, if you want to do whatever naming convention you want for your versions, that's what the user sees. The next section, you have these use permission. Certain features on the phone you can only use if you explicitly give permission to it in your manifest. So this one uses the internet and uses a wake lock. So if you try to use the internet without putting this in your manifest, it won't let you. It'll prevent you from doing that. Now wake lock keeps the screen on, so by default your screen will turn off after a certain amount of time. The wake lock tells the device not to turn itself off. So if you have like an ebook reader, you don't want it to turn off if there's no interaction after a minute. So you'll put a wake lock on. And then, so these two, when you upload your app onto the App Store, it'll there's that description that says, hey, this app needs these permissions, and so it uses this manifest to determine what those permissions are that it's trying to request from the user. And the next section defines your application. Within your application, you have activities. Activities are sort of different screens of your application. Basically, anytime you press, if there's some interaction you do that brings you to a new screen and you press back, there's two different screens or two different activities. David?
So on users permissions, does Google or you said Amazon, do they do a check to make sure your permissions are set accordingly, correctly? Like, do they check to make sure?
No, each time you download an app, you have to agree to those permissions. So anytime you download an app, it'll list a few things. Hey, this uses the internet, this uses a wake lock. Do you still want to install it? You don't set those settings inside your device. It's every time you install an app, it tells the user that it needs those permissions. And the second you agree to that, it'll download it, and then you can use it.
So in the code, there's no way you could say use the internet without specifying it first in the...
Right, you need to specify it here, or they'll have no way of downloading it.
Okay.
Yep. So the application is made up of a bunch of activities. Every activity that you have in your app has to be defined. If you don't, again, when you go to the next activity, it'll fail and say, hey, I don't have this in my manifest. So you need to make sure you list all your activities in your manifest. And then there's a few things about the activity that you want to set. You can put a screen orientation. So by default, does it come up portrait or does it come out landscape? You define that. And then you define what class it's going to when it launches that activity. And then for of those activities, you want to define which one's sort of like the main class. Which one does it start up on? And that is right here, the main. By specifying this as main, this activity will start when it's first invoked. And then launcher defines whether to put it in do you have the ability to launch it from the home screen. If your app is just a service, you don't have to have a launcher, but you still need a main to know where it starts. There is a slight difference between main and launcher. And I think that's it. Any questions about that manifest file? All right, game graphics. So if you make a game, often you'll need to include graphics with it. And there's a few different options. One option is what I like to use is you just take a picture of something and then modify it, make it pretty in GIMP or Photoshop, whatever device or whatever program you want to use to make it look nice. So this is an example of I just took a picture of a game piece I had at home, and then I applied some different techniques to make it look like how I wanted to. So take a lot of photos. That background that's my table in the background of that little piece, game piece, and I've used that for backgrounds in some of my games too. I think word to word also. No, that's a different background, but there are some games that I have that use, my table or my tile floor or different textures you care about. If you want to use something off the internet, make sure it's in the public domain and that you have ability to use that image. And there's a nice site right here of a bunch of sprites that you might want to use. So, if you have a airplane game, then you're in luck because there's some airplane images. For the most part, it's hard to come up with, if you have an idea and try to find a sprite in public domain that represents that idea, it's hard. But there are options out there. There are places that have some basic sprites, airplanes and boats and submarines and explosions. If your ideas are limited to that, then you're in luck. I think that's, you could also try drawing it. I've never had luck with that. If you are good at Illustrator or something, an artist, then that's awesome. But most people aren't, so either find the image online or take a picture and modify it. All right, so you've come up with your app, and you think it's going to be a killer app, and you're excited. What are your options to publish it? There's basically two places you can publish your apps. One's Google Play, and another is Amazon App Store. There are a few differences. They're very similar. Google Play has a one-time $25 fee to publish. Once you've paid that, from there on out, it's free.
Is that per app or per
Nope.
author?
Per author. Yeah, when you sign up for the ability to publish to the App Store, you have to pay $25. Once it's done, that's all you have to pay. There is, you do have to sign your app every time you submit, which is just, you have to run some bat files to actually sign your app and verify it so that there's certain security in place to know that this is a valid app. There is no review process, so no wonder Google Play has a bunch of junky apps, because no one looks at them. You can publish it and no one will look at them, and it's on the App Store. So that's good and bad. You do have a lot of noise out there on the App Store, but it's very immediate. You publish it, and an hour or two later, it's up there, which is nice. Amazon App Store does have a $100 a year fee, but they waived it. They waived it ever since they opened the App Store. So I've never paid for the Amazon App Store. There's sort of a rumor that they'll never really charge you, but they do have that option of charging you eventually. You don't need to sign your app, so it's a little bit less of hurdles to jump over to get it out there. There is a review process. So because people actually look at these apps, it usually takes 2 to 7 days just to get it up there. So you'll submit it, and then a week later it'll be up there. You'll make an update, and a week later that update will finally get up there. They have to review every update, every submittal, which can be a little bit annoying, but it does weed out the buggy software or the dumb app. What else does it say? Oh yeah, and yeah, updates take a while too. So I wanted to show these a little bit.
Question on the Google Play versus App Store.
Mm-hmm.
Since one's signed and one isn't, does that mean you need to have two projects in your
No. After you build it and it becomes an APK. On Windows there's just a bat file you run. You give the APK. You say what type of encryption you want. You give it a key, and it modifies that APK to sign it. So the process is the same to get it. It's just once you have your APK, Google has a few more steps to get it ready.
Is there a cost associated with it?
Nope.
With the key?
Nope. Okay, so here is Google Play. So this just lists the applications, the apps that I have. They do have some nice metrics based on your apps. So if you click into one of these, you can view statistics on it. So over time, you can see how many people currently have it installed on their device. And that'll always be lower than the total installs, because people will uninstall your apps over time. So, and then you can look at, each day how many people are installing your app, and look from there. There's a bunch of other ones. These are basically the two that I look at: how many installs you get per day and how many total installs or current installs you have for that. You can break it down. I guess if you really cared, you can look, what type of devices have your app, what countries have your app. There's a lot of information here if you really want to dig down into it. I don't really care so much, what type of devices people are using or languages, but that information is there. It is useful to look at the app version so you can see, when you release a new update, you can see at what point people change over to the new update to see, are people still back 3 versions back, or have they all updated? This one, 11, I think, is the most recent, so that's good. Looks like there's only activity on the version 11. And then carrier, you can look at what carriers people have. So, you can also get information about any crashes you get, which are also useful. If you're trying to, often bugs that happen don't happen when you're debugging and testing, but they do happen often for other people. And so that's hard to track down. This gives an easy way to see where are these errors happening. Makes it a little bit easier to track down what's happening for these other users. So that is Google Play. I don't know if there's anything else. You can also get your reviews here.
So in your review, is this where you respond to a review?
Google Play, I don't think you can respond to review. Oh, you can reply. Yeah, I guess so. I've never replied to a review on Google Play. But, yeah. You'll get some funny reviews. But that is Google Play. Next is Amazon App Store. You get very similar stuff, just different look and feel. Again, all the apps. And this is a little bit nicer because it overlays all your apps together so you can see how the apps are doing compared to each other. So this is over the last week, and looks like just Risk It is the most popular app right now. And you can see how things are doing, and then breaks it down by the different markets out there. Amazon.com obviously has the most, but there are a few Canadian people that are interested in, and what's that? That's Germany? So this is the summary, and then it'll break it down by app if you want to get into which one, break down the specific app for the different countries or whatever. Besides that, they're pretty similar. So that's comparison between the two app stores. One thing that's I've been interested in, you put in a lot of time, it's nice to get a little bit of compensation for your time and get a little bit of money out of it. Obviously I can't make a living wage off of this money that I get, but it's still fun. I think I calculated once how much I'm making an hour, and it was like $1 an hour, $1.50 an hour. So not great for full time unless you come up with a killer app. But it is still nice to get something in return. So Google Play, I found that because there's so many apps, it's just a lot harder to get noticed. The downloads are gradual, so when I came out with Risk, it took a while for people to see it and start using it, and that climb has been very gradual. But with that, the decline is also gradual. So it seems like you hit a peak after a few months, and then it slowly declines. For Amazon, it'll be a quick ramp up and a quick ramp down. So a few differences between the two stores. Amazon, I found that I've made more money off Amazon, even though the audience is a lot smaller. I think people are just more used to spending money on the Amazon App Store than Google Play. But yeah, they're both good money makers. I've often even tried to change my pricing. Most of my apps are for 99 cents. I tried bumping my Risk app to $2 on both stores, and I did see on Amazon it dropped off, the people downloaded it, but on Google Play it didn't change much at all. And so I've left my Risk app at the higher price on Google Play, which was interesting, I guess. How to get noticed. So yeah, you publish to Google Play, and Google Play has a few 100,000 apps on there. How is someone gonna find you? It's a much higher hurdle if you're actually wanting them to spend money on someone they don't know, a developer they don't know, a game they don't know. So the best way I found is you often make them in pairs, a free one and a paid one. That's why you saw a bunch of duplicates on the store. So Word to Word has 2, Risk has 3, but I'll get to that in a second. Fruitopia has 2. So I'll pair them up. The free one, it's a lot easier for people to download a free version. And then I'll use the free one to be a marketer for the paid one. I'll put in a button that says, hey, check out this game. If you like this, try this out. And I'll limit the free one a little bit so that paying does offer a little bit more features than the free one. But the free one is still functional enough that it's fun to use. It's not totally hampered. So for example, Risk. The free one, you can play a normal game of Risk. With the paid one, you get specific missions where it says, you have to destroy Asia first, or conquer Asia first before getting everyone else, or you have to only attack 3 people each turn in order to win this game, or something like that, where it'll have 25 different missions and you can sort of play a variation of Risk with that. Another key that I've found has been useful is make games that are well known. Hence, I have Risk and Stratego. I guess those are my 2 main games that I have that are familiar. So these board games people are familiar with, and so they're often searching for those games. And if you make one of those games, then they'll search for you. And something that I found useful for that is if someone has made that game before, take a look at those different apps and read their reviews and find what people didn't like about those reviews. And then make sure your app addresses those concerns so that you have something different from the other apps that's beneficial. Okay, so I talked a little bit about this before, but if you have a free and a paid version, make sure they have different packages. So if you remember that manifest file, this package name. So when I did Risk, I originally thought, okay, I'll make a free one and a pro one, and I'll have a flag that turns on or off, and then different parts of the code will look at that flag to say, if I'm pro, then I'll enable this button or do different things. And then I just publish them both and then upload them both. Well, when I did that, if someone downloaded the free one and then decided they liked the paid one, they went to download the paid one. Well, it thought I already had the free one, so it replaced the free one with the paid one. And they got in this weird state where they thought they were the same app, and they couldn't uninstall both, and it was just a huge headache. I think nowadays Amazon will actually check to make sure you don't already have an app with the same package before you publish, so you can't get in that state. But when I did it, I got in that problem, and that's why you saw 3 different ones. This one, you'll notice, it doesn't say here. Let's go home. But it's disabled. One of these is disabled. This one, I think, right here.
What's that last column?
What's sorry?
Total column? What's that?
The total people that have installed that app.
Oh.
So 23 people had installed and started giving me a bunch of bad reviews that it was messing with their free app, and so I had to contact Amazon and have them disable it, and then put out a new one. So the people who liked Risk Admissions and wanted the new version had to pay again for the new one. So a bad situation to be in, so just make sure you have different package names. Let's see. So what I do is it's a little bit annoying, but I don't want to create 2 different projects. So I have the same project. When I'm ready to publish to the free one, I change the sub-package name from pro to free, or free to pro, and it renames all the packages. And then I change the manifest file to point to the correct package name. I talked about this, so find apps that are similar to yours and look at the reviews. That's a useful way of knowing how to do better than someone else to get a little bit more traction. And also make sure someone tests your app besides you before you publish. Because if you publish and there's some bug in there and your first review is a bad one, it really hurts sales. and you can think, hey, I've tested this a lot, but if no one else has tested, that's not a good position to be in. Because you test it a certain way, you know how it works, and so you're going to test it how it works, and then you give it to someone else, and they're going to find a bunch of issues with it. So definitely have someone, a family or a friend, or someone else besides you test it before you publish. And so I referenced this book. I just wanted to put the link on here. This is the book I was talking about, Beginning Android Games, where I got this from. And I did want to show you. So there was one game. So I use Bitmaps for most of my games and the widgets for most of the games. After reading the book, I did develop Stratego with OpenGL. So it is a board game, so it doesn't need smooth animations, but I wanted to try it out. Ready? Wow. Look at that smoothness. So it smoothly moves between the pieces. I could have just have it, jump to the spot, but it looks a little better if you could have smooth animations. Make it feel more like you're actually playing the game. So that's an example of OpenGL. It did take a bit more work to do, but yeah, you'll just want to determine if it's worth it or not to make that step. Any questions? Yeah, Chad?
Is it OpenGL C++? Or is it Java? Is there Java?
I think it's compiled in C, and then there's bindings that allow you to use it in Java or Android. And so I think it's originally C though.
Okay.
So yeah, you can do the same OpenGL development on most other programming languages. They'll have a slightly different ways of interacting with it, but in the end, it's really talking to the same code.
Okay.
Other questions? All right, that's all. Thank you.
Very good,